Hello everybody, thank you very much for being here. Welcome to this webinar, Pole Position Introduction to F1 Performance Engineering. I've got Javi next to me over here.
Hello everybody.
Hopefully you all enjoyed the end of the season. Hopefully you're all ready for a bit of a break from Formula One. We aren't, but we can always try. I know you'll enjoy a bit of some time off work, Javi, won't you?
I hope so, yeah. It's a good time, no?
And we will make a start with our presentation today very, very soon. I've got the chat here. If you can all let me know where you're watching this from, it'd be good to get a good idea for that. I see Pedro from Spain. I can see Guven, which I know has been one of our students in the past. Hi, Guven. Felix from Germany, Spider from India, Luke from Canada. Ooh, that's quite a fast chat. Someone from Brazil, Poland, Spain, Sweden, France, UK. Sarvesh from Oman, UK, Mexico.
We have all the teams, all the countries of all the F1 calendar. We have all the countries, the 24. I mean, they are not 24, they should be 18, 19. Do we have all of them? We got Italy, we got Spain, we got USA, we get
We've got Arian from India, we've got Giovanna from Brazil, we've got Isham from UK.
And we double the F1 calendar in nationalities here.
Yeah. Lovely then, quite a lot of people. Great to see so many people here. Shall we make a start then, Javi?
Let's crack on, yeah.
Right, so welcome to Pole Position, Introduction to F1 Performance Engineering, and we are going to make a start. We're going to start off with what you should expect today, which is an introduction to the world of F1 Performance Engineering. With Javi, our expert performance engineer on the team, we will test your knowledge with some real F1 interview questions, and essentially there are endless levels to the complexity that performance engineering can be. It can be split up into many different parts, and obviously can't be all covered in an hour. There's many different levels to it, and this should serve as an introduction and to hopefully get you interested in this kind of world and start making your first steps. Our complete course will cover a lot more elements than the ones covered here, and we will talk a little bit about it later. But obviously this is a simplification. For hardcore content, you can check out our website for more information. And finally, just the disclaimer that there is no universal methodology for doing any of this. Everything depends on the team, on the particular needs of any team or any category and so on. Every team will do things differently. There is no universal formula, and obviously we're not affiliated with any team. This is just our experience and opinions to share here with you. So,
yeah, and something, if I might add, Alex.
Yeah, go for it.
Sorry to disappoint some of the F1 fans that might be watching us, but unfortunately, we're not disclosing any F1 data or information here. It's all going to be pretty generic, and the data we'll be using for the purposes of this academical webinar is going to be based on other categories, precisely in an LMP1 car. But yeah, hopefully it serves us for this purpose, and you find it still very educative, and yeah, you can take something from it.
Yep, there's no private information here. We don't want to get sued by any teams. Moving on, just a brief introduction about Racetrack Dynamics. We are Racetrack Dynamics. We are this team, and it all started, a bit of a history lesson. It all started at Red Bull when both Javi and I were working there. On the left here is a picture of the first time I actually went to the Red Bull campus when I was still young and didn't have a beard, and quite a long time ago. And one day Javi and I met while having lunch, and we had this brilliant idea of effectively starting something together to help people, teach them vehicle dynamics and help in the world of Formula One. And then a few years later, here we are. We exist, and we're so happy to be here and have you all here. And on the picture on the right, we've got a recent picture of Javi on TV. As you can see, he's our local superstar who will be taking care of most of this webinar on performance engineering. Yeah. Anything else before we start, Javi?
That's it.
Cool. Take it away.
Yep. So we're going to cover the introduction to performance engineering. Let's crack it on, Alex. Yeah. So performance engineering is what I think most people will understand, or what is going through the minds of people when they think of running an F1 car or F1 engineering. And most of the time,
sorry, Javi, stop for a second. Javi, stop for a second. Made a slight mistake. Thank you, chat, for letting us know. Yes, they weren't seeing the presentation. Sorry about that, chat. This is actually our first live stream we do on YouTube. So this whole thing of being a streamer is still quite new to us. As we were saying, not affiliated with any team. Here's a couple of pictures of me and my first day when I visited Red Bull for the first time, and this is Javi on TV a while ago. Yes, I think you've all heard the rest. We're going to get going with performance engineering. Sorry about that, Javi. Sorry about that, chat. Thank you for letting me know. Take it away.
Yep. So what I was saying is that performance engineering is what I think most people have in their heads, in their minds, when they think of running an F1 car, or what they think of an F1 job, together with race engineering. I think they are one of the most generally desired jobs, or this is at least what I had in my mind when I was a kid and I was watching F1 on TV. So it is the full picture of running the car. So all the systems, all that there is the car to it. You need to get a full picture. You need to understand everything. You need to be on top of so many different things. You need to be on top of vehicle dynamics and type performance. So obviously, performance engineering is quite academical as well, quite scientific field that requires a specific background. It requires data acquisition and analysis knowledge, which is not the primary. It's the primary role, but not the role itself, because in order to understand, we will see that in a few slides, in order to understand the data you're looking at your screen or your squiggly running lines in your screen, you need to know what you're looking at first. So that's quite linked to, that's depending on this vehicle dynamics and type performance knowledge. Performance engineering is as well quite operational role. So there is a lot of things related to it that comes with making sure that the car runs safe, that all the parts, components are as they should, that everything is programmed as they should, that all the different, that the car is going to be on track, is going to be as it should, as per spec. So that's a very operational side of the role. It involves, of course, as well, simulation and setup preparation. Again, this is very linked to vehicle dynamics. It has it requires some understanding as well on the power unit. So understanding what the power unit is doing, or all the deployment and harvesting strategies, what are the engine modes you're going to run, and how they're going to play a role in the race, where you want to save, where you want to use more of your energy to attack, to defend, to set your car for a quali lap. So that's as well another side of it. And of course, last but not least, is driving analysis. So you need to understand what is the driving line that makes your driver and your car quicker around the track. There is no clear evident driving line that comes for every track. So it depends a little bit on the race conditions, on the type of the corner, on the different balance limitations that you are having in your car. So of course, this is as well linked once again with vehicle dynamics. So usually in front races, we see some cars doing different approaches around the same corner, and one might think, oh, this car might be, they are getting it completely wrong, or this driver, he doesn't know what he's doing. But then you look at the data and they are ISO lap time, or the driver that is doing the wrong thing, then apparently is the fastest. So you never know. So it comes all very linked together. But ultimately, the goal of performance engineering is to make the car as quick as possible and to adapt to the changing track conditions, Alex. Yep, so going deep, one of the things that is needed, as we said, is vehicle dynamics. So if we don't understand everything that's happening in the cars, all the physics, all the forces, moments, all the temperature impact on the tires, on the balance, the aero, so all these concepts are going to be they are needed. They need to be understood. You need to have a very clear foundation, because without them you cannot interpret your setup changes. You cannot put the pieces of the comments of the driver together. You will never have the full picture. So it's critical to really improve the car performance. So in every step of the phase, from the pre-event to the running the car on the track and adapting on situations you find live. So a driver gives you a complaint about certain things. You need to understand what's happening to the car to be able how to react to that. And that doesn't come easy, but that's definitely the biggest part of the job, which is understanding vehicle dynamics. Then, of course, we need data analysis. All these lines we see in the telemetry, it's not just looking at the data and seeing the lines scrolling. We need to understand what we're looking at. We need a scientific approach, not only to use the channels and the data that we're reading, but also to come up with new ideas, with new analysis, with new ways of how can I plot this with this, to understand trends, variations, anomalies, performance limitations. So the role of the performance engineer is to translate all this data that is running live, all the channels that we have available, into actions to make the car faster. And yeah, essentially that's it. So again, we need to stress the importance of understanding vehicle dynamics, because all the telemetry lines that we look at, they are very colorful, they are very fancy, but if we don't understand vehicle dynamics, we're just blindly looking at the squiggly line. Yeah. So again, driving analysis, it's something also very important, a very important part of the role for a performance engineer. We need to be aware of drivers are professional. They are at pro level. They've been doing this forever. They know quite well what they're doing. But in a very in a high-end sport where margins are so fine, are so thin, and cars are pushed all the time to the absolute limit, sometimes they need just a little bit of help and suggestions on how they can do things differently or better, or maybe sometimes it turns out that adopting different lines and different strategies to how to approach a certain corner can also solve some of the balance limitations that the drivers are seeing on the track. Analyzing as well if there is anything relevant on what competitors are doing, if there is any takeaway, anything we can do better to improve. So yeah, really understanding how we can make the car, how we can complete the lap quicker by doing things differently, braking earlier, or turning it more sharper, or delaying, or doing whatever. No, so just looking at the driving analysis itself. We said before that the performance engineer is responsible for it will be nonsense to say that the performance engineer is responsible for this, because there is so much work in detail behind that cannot be covered by a single person. There is a dedicated team behind, but the performance engineer is also responsible of putting it all together, like making sure of what is going to the track, what is going to be programming the car, and how things are going to be used by the driver, how the different engine modes, and they need to be adapted. So they are also the link with the power unit department, and as we said, managing and adopting the different ERS strategies depending on the category, not only power unit, but also other controls like torque curves and engine maps, all the tools that can be played with in the car that are involved in the power unit. And yeah, we said that There are other tools behind the power unit. So there are many mechanical adjustments that can be done in the car. There are other aerodynamics adjustments that can be done as well. Some are involved in, some are part of the tire department, some are part of the aerodynamics, suspension, whatever. But there are many other adjustments that are part of the performance engineer duties to find out on track, which are the rotaries and the maps, everything that can be optimized live by the driver with his toggles, rotaries, buttons on the steering wheel. It's not about finding a good solution for the lab, but about finding the perfect solution for every one of the corners. And if you look at the snapshot that I have here for Monza, I believe 2023, 2024, maybe. Yep, you can see that was 20. I don't recall. You can see the 6 first drivers. They are within 0.2 of a second. So of course, you cannot just settle down with a combination of adjustments that are fast on the track. You need to chase perfection on every corner, and this higher level of adjustability is given by all these electronic tools that you can play with that involve some things like engine shape, brake shaping, how the brake balance is going to change with pressure, brake balance, you can adjust corner to corner, rotaries for differential, for different regimes of the corner, entry, mid, exit, high speed. So there are so many different things that can be played with, really. And any phase of the corner or any corner that is not completely optimized for is performance left on the table. And in a sport that is so competitive as F1, this is clearly unaffordable. Yeah, taking a look at what does Formula One weekend look like. So of course, it's race engineer duties normally to specify what is the spec of the car, what is the package that will be run on the track. Performance engineers is supporting him in this matter, but there are so many departments and so many things to look at the car so in detail that requires so much attention and so much expertise and in-depth work that cannot be covered by 1 or 2 people. So it becomes impossible for them to look at all of sections of the car individually. So that's why we have other departments that they are interacting constantly with performance engineering and also with race engineering, which are the tire group. It goes without saying what they do, vehicle performance, which gives another hand to the performance engineers, helping to set up suspension and find out limitations. And they are basically the extra support for the performance engineer where they don't have the ability to look at things in detail alone. We got our performance group. So I'm sure you had it on TV. I got contact with Carlos on T3. I think I damaged my end plate, whatever, my front wing. Can you check what's my damage? And then they say, okay, your losses are 10 points of aero. We heard it in the radio. So there is a dedicated team of engineers looking at all the aerodynamics of the car in real time based on the sensors that the car is running to detect if there is anything not working correctly in the car, anything that is working not as expected, and then they flag it up and report this to the engineers on track. Some of these engineers, this aero performance engineer, can be also on the track, and this is reported to the people running the car, race engineer and performance engineer, so they can take action based on that. So imagine we're running the car. They tell me I have front damage, and then I got losses on the front. I'm losing some points of aero in the front, and then I know I'm going to be more front limited, and then I know I'm going to struggle to get some rotation. Then I can maybe, if I'm the performance engineer of the car, I can try to fix that with some brake balance or whatever, or even with some other differential settings. So they are quite important group. They are very important part of the team during the race weekend. We got control systems engineer looking at all the controls, all the electronics of the car, everything that is can be programmed, all the ECU, all the electronics. Really, it's a very complex field. power units engineers, as we said, looking at in detail into the engine, into all the systems on the engine, on the hybrid engine, on the electrical, on the batteries, on the performance on the engine, if there is any anomaly with the temperature, pressure, that everything is running as it should, plug-in reliability or performance issues. And again, we have the strategy group, which I think we all know. So all these groups are constantly interacting with performance engineers and with race engineers, and they are helping them. So the role of the race and performance engineers to try to put it all together into the best or the fastest possible package for a car to run on the track.
Thanks, Avi. Next, I'm going to introduce a bit of data acquisition. I asked Avi if I could do this introduction because I've always been a fan of it, and I feel like it lies quite well with what I've done in my life, both professionally and in my time at university, Formula student, and so on. So I think at the end of the day, there's two main elements to the data that you need to get, which are effectively the ones to do with health, the ones that can ensure that you finish the race, or that can flag up any issues that might be correctable in time and prevent an issue from happening, like we see over on the left. Or we can also do it in terms of what data is going to give us the most important data, the most important insights, and the most important relevant data on how we can improve the performance of the car. Because going back to health and reliability, a very famous quote: "In order to finish first you must finish." And at the end of the day, it's just really true. Formula One cars and just motorsport in general has plenty of sensors in a lot of different areas of the car, and if you can get an early warning signal of something going wrong, excessive vibration, excessive temperature, excessive whatever, and you're able to correct it in time, that could very easily mean the difference between a DNF and a P1 or finishing a race correctly and so on. So there's loads of different systems for checking this, alarms, limits, lots of different strategies for what to do in each case. So that is effectively one of the most important areas of it. The other one being, how do we extract the most performance? How do we identify where the lap time gains can be obtained at any particular lap, any particular point, using the data that we have? And how do we extract performance from the car using the sensor that is available to us? This is something that can sometimes be a bit of a harder task, and sometimes can be a bit easier. A lot of things in F1 can be very difficult to measure, if not impossible, and has to be estimated and simulated and so on. Whilst other things can be very directly measured. So there's always a big element of, let's not just look at the data, let's interpret it. We're not just looking at squiggly lines and making colourful plots on a screen. We're actually trying to obtain good data out of this. And that is why this world of performance engineering is so big and so complex. And in terms of data acquisition, as we mentioned, F1 cars and motorsport in general, cars are full of all sorts of sensors that will measure pretty much all kinds of things, whether that is acceleration or pressures or temperatures, velocity, steering inputs, even sometimes the strain on different elements of suspension using strain gauges and so on. And this is what allows engineers to effectively validate simulations and validate setup changes, measure whether there is good correlation between what we think was going to happen on the car and what actually ended up happening. And again, depending very much on category to category, this can all be interpreted. It can sometimes be interpreted live. Some data is fed live, whilst some other sensors and so on are effectively downloaded after the session, and then they can be interpreted later with more time and trying to come up with insights.
Just a point here, Alex,
Yeah.
if I might.
Go for it.
Jump in. There is a good reason why we named these slides data acquisition and not telemetry. I'm sure we all have heard the word telemetry, and when we think of the data of the car that has been run on the track and that we look on the screens later, we think of telemetry. But the fact of calling it telemetry, it means that it's running live and we have live access to it while the car is running. So while this is true and this exists in Formula One and some other categories, it is not present in all of them. So the right way, we believe, to address it is to call it data acquisition. And sometimes this data that we acquire is running live, which makes it telemetry, but not necessarily all the data we get from the car is always telemetry. So telemetry necessarily implies that this is running live.
Thanks, Avi. Yeah, no, that's pretty much it from me. At the end of the day, it's all about using this data to turn it into actionable insights, whether that is from lap to lap, or from a weekend to the next one, or from a season to the next season. All data can be valid, can be useful in different scenarios, and that is what this is all about. Back to you, Javi.
Yep. So as Alex was saying, the car runs a very big, large amount of sensors. So there is no limit on during the sessions on the practice sessions on how many sensors we can run. Then obviously during the race and quali, there are some limitations on what we can run, what is permitted and what not. But during these free practice sessions, you are free to run as much as you want. But the problem comes associated with the weight. No, with every sensor that we add adds weight to the car. So there is not just the sensor; it's the wiring loom. So the cable you need to transport, from the ICU or your data logging module to the sensor itself. So it's going to add weight. Maybe not a lot for one sensor, but if you multiply it for all the sensors that we have, we end up with quite a heavy wiring loom. Of course, this adds weights, and there is an important penalty on the weight on the car. We know that. I mean, depending on the track, depending on the car, blah, blah, we know it's roughly 3 tenths per 10 kilos, give or take. So the usual approach or strategy, is whenever you have something relevant to measure on your car, you try to put as many sensors as you need to get the information that you need. Then you capture that information, you validate your models, you correlate whatever you need, you extract the information, and then when you reach your conclusions, then you can just dump the sensors that you don't need to run during that are not needed for qualifying or for the race when you actually need the performance on the car. So there are so many sensors that it will be impossible to focus on all of them during this 1 hour webinar or even during our 14 hours course. So what we're going to do is we're going to cover what I believe is the holy grail, the 3 main sensors that I will take to apart from throttle, steering wheel, and brake pressures, that I will take to a desert island, or that I will always need, or that are more needed to understand data from the car, to correlate models, and to validate them. So we go ahead. First off, we got damper potentiometers, POTs or POTIs. Damper potentiometer is nothing but a linear sensor that we run on the suspension inboard that is capturing the deflection of our inboard suspension, how much our elastic element is compressing when there is a bump, whether it's load transfer or whatever. So first, it is very important. First, because it tells us, together with other sensors, of course, but you need this to understand if springs, dampers, and all the elastic elements on the car are behaving as expected when you go on the car. When you send out the car out of the box. Imagine you for whatever reason you fit the very, very wrong anti-roll bar, so you will start seeing very, very wrong displacement in roll in your car, so you know something is going down, so you can track all these anomalies. So first is the first order effect of understanding if there is something very wrong happening with the car. Then it comes understanding go back, please. Understanding certain things like bottoming or the travel of the car. You can, from the displacement as well, you can infer the accelerations on the you can optimize as well the right component of the car, but essentially you cannot do any correlation work without the damper POTI. They are involved in any single channel calculation or yeah, or calculation I can't really think of. So they are super needed and super basic. So completely needed. Then we get the push rod or pull rod strain gauges. So the strain gauges are these little cells that I'm sure Alex can point to them in the picture. These little cells in yellow.
1 second. The little cells in yellow.
Yeah, these little cells on the pull rod or the push rod. So what they are capturing is they are very fine, precise sensors which are calibrated to measure the deformation of the element element in which it's placed, and then based on that, it can infer the force that is going actually through it. So this is also a very key element to understanding correlation in the car. It can help you to understand the load transfer under braking, cornering, acceleration, basically in all the dynamics on the car. Can tell you it's something that the aero group will be very pissed if it stopped working, because they will be effectively not blind, but they will have a very tough job trying to figure out if there is anything going wrong with the car, because they measure the total load going on the car, effectively the aero. Can help you understand if you are hitting too much the curves, if there is anything you need to look at. If if a driver complains, yeah, I have a lot of very massive harsh hit when I hit this curve. You can see this with this data, and again, essential for model correlation. Then we get the IMU, or the inertial measurement unit, which is this box, this gauge that we place in the car, and this measures the car's acceleration in all the 6 degrees of freedom, so vertical, lateral, longitudinal, depending how you look at it, and also the rotations on the car, yaw, pitch, and roll, right? So this is also needed to understand what's going on with the car, driving dynamics, and to validate all the dynamics of our models.
Next up, we're going to be asking a couple of F1 interview questions. So we're going to throw these into the chat. We're going to let you answer on the chat. We'll give you a bit of time to think about it. These are all F1 style interview questions which you could reasonably expect at an F1 interview, depending on the role and so on. We're going to go for it. So the first question would be, what acceleration does an IMU read in the Z-axis component of a car when it is standing still? We'll give everyone a few seconds to answer in the chat, and then Harry can release the answer. Do you see the chat, Javi?
I do not.
Okay. Next, I'll... Guillaume saying gravity, yes, gravity, so 1g, acceleration due to gravity, weight, 1g, 9.81, 1g, minus 9.81 meters per second squared, minus 1g, plus 1g, gravity. Most people agree it's some variation of gravity. Someone said gravity plus the weight of the car. Would you like to release the answer, Javi?
Well, I think most of the people agree there. The answer is gravity. Whether it's going to be positive or negative, it really depends on how you place your AMU, but generally we're talking about the value of G. Of course, when we look at the data on the car, we need to we do the calibration of the sensor, we do the offsets, and then we make sure that it's reading 0, 0, 0. So we look at relative to the gravity acceleration, no? But per se, before calibration or anything, it will be reading G effectively, as people were saying in the chat.
Lovely. I'm going to move on
to
your lap.
So we're going to be looking at some of the basic channels that we'll see in our telemetry. Alex is going to be we're going to do it together. Alex is going to be reading a little bit the comments on the chat. So we'll be starting from the top to the bottom, and we want to see if people can figure out what these traces mean, and see if we can decode it together. So first of all, what do people think this first blue line represent? I think that's an easy one to start with.
Let's hear it, chat. Speed, steering input, tyre temperature, GPS speed, longitudinal speed, velocity, a lot of speeds. Most people say speed, vehicle speed.
You can go ahead, Alex.
Click. Correct. It is speed. Congratulations. They got it right.
You want to take it away, Alex?
So for the next one, you mean?
Yep.
Yeah. Okay. Yeah. So second one. What have we got for this second one? What do we think it is? Throttle percent, throttle input, RPM, TPS, throttle input, throttle, gas pedal, braking, throttle input, TPS, throttle position. Louis was saying TPS.
You can go ahead, Alex.
Very well done. It's the throttle percentage, usually between 0 and 100. Do you want to do the next one, Javi?
Yep, go ahead with the next one.
So what do we think the next one is? So the yellow one in the middle. What are we thinking that one is? Steering input, lateral acceleration, steering input.
The values of a stock.
The what, sorry?
The values of a stock. The price of a stock.
Took me a while to get that. No, this is not Apple stock. This is indeed steering. Okay. Steering wheel angle, or SWA.
So far we got the basic ones, so most people have gotten it right. Let's see if people can get the next one. It's a little bit more tricky. Let's see what people think for this blue one. Not the cyan, but the blue, fourth one.
Yeah. So next one from the top, what do we think it is?
Let's allow a little bit more of time for people to think this one.
Take your time and drop it in the chat whenever you are ready. I'm hearing balance, I'm hearing differential, I'm hearing G-sensor, I'm hearing lateral acceleration. Some people say the rate of change of steering. Say again?
You could think it is related to steering, so it's not super far from that. This is not an easy shot, I must say.
Yeah, it does hold some similarities to steering wheel angle, so you could expect them to be somewhat related. Lateral acceleration, steering derivative, steering correction, yaw velocity, damper deflection, throttle, yaw rate. I mean, there's a lot of variation.
Some of the answers we are seeing, they are not right, but they are not like super wrong. Like they could be, it's difficult to know this without more context. But some of the answers that I'm hearing, they could make sense without, because they could look very similar. So if we unleash the answer, this one is a little bit trickier. So this is the understeer oversteer angle channel. This is a channel that is used to evaluate balance. I think we got it somewhere there. Positive means understeer, negative means oversteer generally. And we cover a little bit more in detail how this channel is formulating and how it's of use in the course. But that was the answer. And then to wrap up this slide, what are people thinking of the last channel, the cyan one?
What's the one at the bottom, chat? Lateral G. Someone says cool statistic. brake pressure, G-force, brakes, engine RPM, G-force lateral, combined G-force, energy deployment, brake pressure, RPM. I think most people are between RPM and brake pressure. I've heard
Really?
Earth deployment as well.
RPM. Okay. Hopefully we'll clear that up later. You want to unveil the answer?
This is indeed
acceleration.
lateral acceleration.
I think the point that we can, I mean, one of the hints that we get is the value that it tends to 0 when we're in the straight, when we're accelerating in the speed, when we're in the straight, yeah, and being somehow related to the steering wheel angle trace. But yeah, we can go ahead to the next slide, see what there is ahead.
Yeah, another element of, well, effectively, whenever you would look at RPM, you would usually see different, like really quick shifts in RPM due to changing gears as you increase speed, which is not the case here, which is why, well, amongst other reasons, this can't be RPM. So yeah, lateral acceleration, as we said. Next up.
So what do we believe? It's the red one?
Top one at the top. What do we think it is? People saying RPM. Brake pressure. A lot of RPMs this time. RPM. Revs. Should we release it, Avi?
Go ahead.
This is indeed engine RPM. You can see the characteristic sort of shifts and, well, the spikes of quickly changing gears.
Classic serrucho profile.
Like a saw, yeah, like a kind of, yeah, like a saw profile of really sharp teeth.
Yeah, I always forget that word. Yep. Then we got speed, which we already covered before. Then what do people think? This should be an easy one. What do people think on the next one, on the orange?
Third one from the top.
Yep.
Brake pressure, braking.
Yep.
Brakes 100% sure. If you're 100% sure, SK, then I guess we have to call it brake pressure.
Brake pressure. Then we go ahead. What do we think about the second last one?
So that orangey one at the bottom.
We should get a pretty good hint with the engine RPMs, hopefully. If we see some of the spikes.
Let's give everyone a bit of time. Someone says engine load. Someone says acceleration. Longitudinal acceleration, says someone. Longitudinal G, wheel RPM, ERS.
Yeah, send it, Alex.
This one is longitudinal acceleration indeed.
And then the last one has some similarities with the third one. Let's see if people
can get before you do that, do you want to briefly comment on why we see the spikes? What causes the spikes? Because they're quite characteristic of this particular plot, aren't they?
Yeah, they are They are related to the engine, to the gear shifts that we see. The RPM drops that we see in red, they usually match these spikes that we see in G long. Is this massive kick, from the engine? We're doing this process of changing gears.
Yep.
It could be when you have these spikes, especially in braking, because when you are downshifting as well, so you keep having this, if things are not properly calibrated, you keep having these spikes where you're approaching the corner, and they can be quite disturbing. They can induce real slip and instability. So, important to get this right.
Final one then.
Yeah, final one. They are very similar to our third one. So based on that, what do people think we can have there? And then we have another question based on that.
We've got people saying brake bias, people saying ERS. Last one is tyre slip, brake temperature, brake travel, brake bias.
If I may add a little hint, they are very, 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 very similar in shape to the brake pressures, which is you will never get that similarity in brake pressures with the temperature because you got thermal inertia, you got cooling, you got so it has to be something very clear, very specific that can be very, very linked to the brake pressures and to the braking system. Let's see if we can get that. It's not super straightforward, but hopefully someone can get it.
Brake position, brake pedal, tyre
And
temperatures.
we have two channels. We got two channels.
Brake pedal position, G.
Yeah.
Shall
Shall
we
we?
release it?
Yeah. So the
This is
answer
the
is
brake
brake
torques,
torques.
yes.
There is a good reason why brake torques are. Let me check something very quick. Actually, let's go ahead. I was thinking, what is the next slide? So go ahead with the slides.
Yes.
Get a little bit more technical now. So question number 1 for the people in the chat, why do brake pressures have this shape? Can anybody tell us? This Dorito shape.
Question for the chat, and why have we got that shape? People are saying trail braking, degressive, said someone. Pressure is relieved slowly. Trail braking. Should we? Do you want to answer that?
Okay, it's in that line, yes. So we see it's a very, very abrupt spike. So basically, you're running an aerodynamic car, which has, the faster you are, the more load you have, the more capability you have to brake and to slow down the car because you got more downforce, you got more capabilities to slow down, and then you want to step on the brakes as hard as possible. But then, as the car is first, I mean, people are getting that right with the trail braking. As car is reducing the speed, then it reduces the amount of grip it has, the amount of longitudinal force that the tires can produce without overslipping. So that's why, as the car reduces the speed, it is necessary to back off on the brakes a little bit, because if you kept up that shape, just like a step, you will end up locking the tires. And again, you need to back up a little bit more because that is linked together with the steering wheel angle, and as people were saying, with the trail braking procedure. So that's the answer to question number 1. I believe there is a second question in this one.
Yes, there is a second question. Just before releasing it, something I forgot to say at the start. All of you will be receiving certificates of attendance for coming to this webinar. We will have instructions at the end of the slides showing how to obtain it. We will email it to you. You just need to fill in the form for us. With that said, question 2. What brake channels would you use to establish your brake balance?
So we got brake pressures and we got brake torques. Which do we believe we want to use for our brake bias? Let's leave that one sink.
Let's hear it for the chat. Brake torque. I'm seeing about 10 people saying torque. Everyone's saying torque. I guess we're going to have to call it torque then.
Yeah, the answer is torque. For those who don't see it so clear, I mean, we got a further expansion of this on the course, and why it makes sense to refer to the brake bias with the brake torques. Now, Alex, if you go ahead, I believe there is a bit more of telemetry to see. So this time we're going to give it I'm going to take it over and walk a little bit through the temperatures of the tires through a lab. You can see if you click there, we got some things that we can look at. First off, we have, so all the lab is roughly, the temperature we set our tires to open the lab do matter. We will see later. We have temperature evolution here on the high-speed corners. In this right-hander, we have a lot of energy going to the left tires, driving this temperature increase. If you go next one, we see we target our to start the lap certain temperature. Still, we have some areas where we're kind of coldish. We see our tires are, so the white line I've traced there, it's around 100 degrees. So we can see there the rear, I believe the front tires are as cold as 80 degrees. But if you click again, Alex, then we have other sectors where we're running hotter, hotish. We are overheating the tires. We're around 120, 130. So as you see, the temperatures they have a very narrow window depending on the category and everything. But we need to get it right for the tire to be operating properly during the full lap. When we're talking about the race lap, we know that, give or take, we need to balance our temperature. So the value that we have in the beginning needs to more or less match what we have at the end. If the value at the end is higher than the value at the beginning of the lap, then we keep increasing the temperatures, which is not sustainable because we keep digging the tires a lot. But and we're kind of managing as well somehow during the race. But during a quali lap, where you want to send everything, you need to target your temperature starting the lap, so you are globally okay. You're never going to be perfect in every corner, but you need to target it somehow. So it doesn't matter if you overheat it at the end of sector 3 or you get too cold at the end of sector 3. What you need to get is really the start of the lap temperature of the tires that gets you the best quality lap, the best push, non-sustainable lap. So here we see some places where we're too cold, some places where we're too hot, but generally this is the opening the lap temperature that works best for our tires. Go ahead, Alex. We can see as well as that generally the straight cools down the tires. Of course, left-handers put more energy. Left-handers put more energy on the right, and right-handers put more energy on the left-hand side of the tires. On the left tires. Then we have other channels, more sophisticated channels like tire saturation, which measures the percentage of the tire usage depending on load, temperature, and the estimated force on the tire. So essentially what we're doing is with the load, the slip, the temperature, and any other factors, we go into our tire models. So that's why, again, our tire models are so important, Alex. We covered it in one webinar. We covered that as well in detail in our full course. And then with that, we can establish what is our budget, what is the amount of FY that we could be using in the corner. You can do the same for FX, longitudinal force, when you're braking or accelerating. And then based on the estimation of the force that you think you're putting on the car with the IMU, with the push rods, with everything, with all the things you got on your car, you can infer how much force you're generating in your tire. And, based on how much you got available, you can understand how is your tire saturation or how much you are really exploding your tires in the direction that applies.
Cool.
And
Next up,
yeah,
go for it.
Yeah, we're gonna go next with telemetry F1 interview question. Hopefully, this is a little bit more challenging for those who could answer all our previous questions so fast. So let's go ahead. So here I'm showing it's the channel I'm showing there is aerodynamic balance. It's going in the y-axis we have the percentage, and in the x-axis we have velocity. As we can see, the aero balance goes, in this case, for this specific car, in this case it's going forward with speed. But there is quite a big deadband, quite a big hysteresis, which for those of you who don't know what hysteresis is the phenomenon where you don't get the same response of your system regardless of the direction of where you go. So if you load it, you get something, and if you unload it, you get something different. So this deadband that we see on the data, it's hysteresis. So my question for the people that are watching us, what do you think is causing this hysteresis that we see on the data? What is shifting my aerodynamic balance in this scatter plots that I produce here?
This is a very interesting one, and we're going to give people a bit of time to think about it. But we're seeing tire temperatures or tire wear, wind effects, temperatures, tire loading and unloading.
Wind effect is a not bad one. It's not a bad one.
Rate change, said someone. Weight distribution change. Engine usage, tire grip, tire deflection.
We want Alex to unveil and to reveal one hint for people watching. You just click.
Okay.
So what I can do is I can give colors to my scatter plot, and I can color my scatter based on the acceleration or the longitudinal acceleration, and then I can see a clear trend. So then I can see that when I accelerate, it's kind of shifted rearwards, and when I kind of brake in this loop, it's going forward. So based on that, on this clear trend with longitudinal acceleration, what is then the answer? Hopefully people can get it now.
I'm seeing tire and suspension hysteresis, friction loss from suspension, wind speed, pitch angle, height of the ride heights, pitch, rake angle.
So some people are getting that right. It's actually pitch. So whenever you accelerate, the car is going in this direction. When you brake, the car is going in this direction. And as we know, there is a sensitivity to pitch angle in our narrow map, not only in performance, but also in aerodynamic balance. So this is what is causing it. And that's why, again, we can never look at squiggly lines alone. We need to understand vehicle dynamics. We need to use it to make meaningful conclusions and to know what we're looking at now. So that's it for the Formula One interview questions.
Yep. Next up, I'm going to take it over from here because I'm going to ask Javi some questions. We're going to talk about how to become a performance engineer, and this we wanted to be a very a friendly chat. So I'm going to get into this camera. Got a couple of questions for you, Javi. So first of all, how long did it take you to become a performance engineer, and what path did you take to get there?
31 years old. So I was born in Cartagena in 1994, and then 31. No, right. So I was very linked to Formula student. I did a lot. I did a lot of research. I read a lot of books. I got so obsessed with vehicle dynamics. All my professional roles ever since, they've been related to vehicle dynamics. So I think it makes it like almost 10 years, give or take, since the first time I started to work in the field, either an academic or a professional level. So always really on the branch of vehicle dynamics.
What mistakes might someone who's trying to break into performance engineering make if they don't have a sufficiently good background in vehicle dynamics?
It's a good one. I think the first problem they might encounter is they might not really probably get the jobs they want. So it's a very appealing position for all the racing enthusiasts, as I can understand. It was also for me, but you need to do all the understanding of vehicle dynamics behind, and you cannot just go and apply to one of these jobs because they're going to bomb you with questions. And all the people that are serving these positions, they come from, they've climbed the ladder. They really know the foundations of the car. And it's only when they have all this clear that they're able to take things, the operation of the car, to manage the setup and So there is a long process with it. You cannot just simply, so it's a lot of learning behind, a lot of vehicle dynamics learning.
Yeah, that links into my next question very well. What does a performance engineer need to know the most of?
Vehicle dynamics, and vehicle dynamics. As I said, without vehicle dynamics, I mean, you cannot really understand what the driver is telling you, what you want to adjust in the car, and it's not trivial. You need to get everything very clear. It's vehicle dynamics in steroids, really.
Yeah, and why is vehicle dynamics so hard to learn?
I mean, some units have structured courses, but there are not many, and they are not so accessible. They are usually very expensive. There is info there. There are some books, and people who want to learn. They really take the books and they eat them. They really they read all of them. But it's a long way. Uh, it's not something you do with just reading a few chapters of one book. Like clearly understanding the full picture here, it's a lot of things, how they interact together. What do you learn before? You learn about suspension, about geometry, you learn about the elastic elements, about damping, about ride. Do you learn about tires? Do you learn about balance? Do you learn about, it's a lot of things. And what comes first? What is this? What is that? What is star model? Is it trying to put all the bits together is what I think is challenging.
Yeah. Would you say you made any mistakes on your way to becoming a performance engineer? Is there anything you would have changed or anything you would have liked to have?
I think I've made many mistakes probably in my life and professionally, but I think I kind of took the right approach. I kind of build up, the economics knowledge until, this uh, kind of reached to this position.
Hmm. And what would you say is something that we do or we have done to help students, learn vehicle dynamics and land jobs in F1 and so on?
Well, to read, and learn.
No, so I meant what have we done as racetrack dynamics?
Oh, I mean, probably this one is better for you, as
Yeah,
the
yeah,
director
well,
of the.
yeah, sure. Well, yeah, at the end of the day, yeah, we revolve around sort of teaching vehicle dynamics to everyone. So we go from like the very simplest of vehicle dynamics explanations, which you might see in one of our reels on Instagram, um, to our complete guide to vehicle dynamics in F1. Super complex stuff, a lot more interesting, a lot more deep into the weeds of the vehicle dynamics and so on. Um, and I guess it's just really what we do. And we had some very good news about a month ago, where one of our students from September managed to get a job at Aston Martin F1. So at the end of the day, it's we've really we've really helped a lot of people. How either get jobs in F1 or have a better chance at their interviews
And
in.
even people that already have work in F1 that they want to learn about something that is maybe not in their area, they want to do a shift, or they're just curious. We got also people from other F1 teams.
Yeah, yeah, yeah. And I mean, for anyone that wants to effectively understand this further and take this a step further, let me change. Um, a brief mention of the Complete Guide to Vehicle Dynamics in F1, which is our complete course covering everything you need to know about vehicle dynamics, taught by our expert Javi here. It effectively condenses his 10 years of vehicle dynamics learning into 12, 13, 14-hour courses, depending on how long it takes. You get to chat to us for the entire time, and you also get a free one-to-one session with us for questions or career advice and so on. You get to keep the slides as well, and it covers everything that you need to know: tire performance, lateral dynamics, weight transfer, suspension design, and performance and simulation. It's effectively like this webinar, but on steroids and for an entire weekend. We've had, great feedback from our students, and it's happening on December 27th and 28th for any of you that might be interested. And it's suitable for anyone with a high school background in maths and physics. So it's highly recommended for anyone that wants to take F1, getting a job in F1 or motorsport seriously. And it's actually a subject that is taught by universities a lot, as in they get us to teach this course as their vehicle dynamics subject. A lot of these masters courses really thousands and thousands of dollars. For us, it's only $299 on our website. So we want to make it accessible to pretty much everyone around the world, and that is effectively what we do here. Um, Javi, can you recall any of the feedback we've received, or anything you would like to say about this course? What do you think? What students normally think of it?
I think, um, last time we got some really good feedback from some students. They were, I mean, I was doing my explanations and I could feel like some of them were kind of lagging behind. I could see the confusion on their faces. So we stopped the explanation. I picked them up. I could see the faces. So everybody in the seminar has the webcam connected. It's not for me to judge whether someone is paying or not attention, but if someone is paying attention and I can see this is starting to drift away from the topic or having struggling or difficulties, then I can stop the explanation. I can go in this one-to-one with him and see if I can help it. So we do not move forward until everybody gets an understanding of what we're covering. So this is the feedback we got from one of the students. He know how I could perfectly read when he was starting to turn off, and then I got him, and then we could answer his question, and then he.
Yeah, he got a little bit confused, and Javi spotted it immediately, and he was like, "Oh, are you lost? Do you need any help?" And he was really thankful about that, and you then gave us like really good feedback and so on. Reading a bit on.
It's not only about teaching, but about having this one-to-one, like guiding people by the hand in one topic that is not easy, that is complex, and it's easy for people to get lost. So this is what I think we do best.
Yep. Kind of question of so as a 23-year-old, it's not too late, and I'm a female. Absolutely not. I mean, I'd say most of our students are probably between 17 and 26 kind of age, mostly. Heavy.
I mean, to be honest, we've got students from 13 to 50 years old. So
Yeah. I mean, we've had a bit of everything.
we need to pull out this metric. We need to do an average. We need to do
we need to do an average. Yeah, I'd say most people are sort of within that age range of late high school or university age. But we've literally had people already working in Formula One teams that have wanted to make a change. People in high school that like they're still doing the high school exams and everything, and they just want to be really prepared and so on. So it's absolutely not too late. If you have any questions about the course or anything, you can both ask us now in the chat, or you can send us a DM and on a message on LinkedIn or on Instagram and so on. We're going to announce here the certificates. So if you want a certificate of attending this course, you can go on racetrackdynamics.com/certificate, as you can see on there, or you can scan the QR code. And I'm also going to put it in the chat for you to access.
I'm going to do mine too.
Yeah. I'm going to put it in the chat. So any of you that want a certificate for being here, you will have it sent within the next hour, roughly. But it could take a little bit longer. But yes, that is the end of the content for us for now. So first of all, thank you very much for being here. You can follow us on Instagram, LinkedIn, TikTok, YouTube Shorts, YouTube normal, YouTube, everything. We're literally everywhere. Thank you very much for being here. And now we are going to be open to questions. So I am going to change this into just you and me, Javi. And we're going to be taking some chat questions. Anything you want to say, Javi?
I'm cool.
Cool. How many spaces are in the webinar, in the seminar for December? There's like 7-8 spots left, I believe. Not that many. And there's about 250 of you in here. So it could sell out quite quickly. The one in September sold out. And that was massively successful. So if you want to access it, do not miss out. And yeah, more questions. What you need? Someone asked, how relevant do we think Formula Student is? Javi, do you want to take that, or should I do it?
101% relevant. Very relevant. I mean, for there are ways of finding your way to F1 without Formula Student, and there are people doing that. But I always say that people that have this Formula Student experience, they usually are successful in Formula One. They got more chances. I think Formula One teams can read that not only because they have the technical skills that they need, because they have learned that, already applying it to the student race cars, but especially because I believe there is a different mentality that people that studied in did these Formula Student projects have in their minds. So they are relentless. They have always this willing to learn. They have this work ethic. They are happy to do. I mean, they basically work their life, during this the university years for no remuneration, for no money. So if that doesn't speak about passion, who else does?
Yeah.
What else?
Yeah, just to add on to that, something I usually say, I went for an interview at Mercedes F1 a few years ago, and there were 6 people there getting interviewed, and 5 of us had done Formula Student before, and I think it's a good representation of what it is. You don't need to have it to get a job in Formula One, but it is highly helpful, and it will really help you out your odds in the interviews and so on. We've got some of the questions. Something about the experience needed to become a performance engineer, Javi. I think if you could you briefly just go over your work experience and effectively how your your job role, your job title has evolved over the years into becoming a performance engineer.
Well, I started off working as a tire engineer for a tire manufacturer. From there, I did that was a short stint, so half a year, I believe. Then I moved to Formula 2, 3, 4 team in north of Italy, where I was working as simulator engineer for almost 2 years. After that, I did another longish stint of 2 years doing design and development of road cars for another company. And from there, I moved to Red Bull. They asked me the question in Red Bull. So why did I believe that if I was that what I learned in vehicle dynamics for road cars was relevant to F1? And I told them, listen, this is exactly the same thing. So nothing changes. You can apply the same principles. So I'm sure you know what is self-aligning moment, what is yaw rate, and what is you know it doesn't change really from one thing to another. So then from there, joined Red Bull as a vehicle dynamics engineer for 2 years in the vehicle performance group, and there moved to where I am now, where I've been serving for almost a year already as performance engineer in the Audi project here in Switzerland.
Cool, thank you, Javi. So at the end of the day, I think, as we said, one of the most important components of performance engineering is vehicle dynamics itself and really understanding, how a car works and how it operates. And it's why effectively why we like so much the field of vehicle dynamics and why we do what we do. Thank you, Javi. I've seen another question about how to effectively get more interviews with your CVs. That's something we actually take care of as well.
Can I get that one?
Yeah, of course.
Uh, Alex is your man. Alex has, I believe, the biggest interview success of all the F1 history. Alex, do you want to talk about your crazy stats?
Yeah, so a few years ago, I applied to 23 F1 jobs, and I received 5 interviews, 2 from Red Bull, 1 from Williams, 1 from Mercedes, 1 from Aston Martin. And since then, I'd say I'm pretty qualified to advise people on, especially in the early career section, on how to improve your CVs, how to show off your expertise, how to format it properly, how to make it stand out. To
And you recently have helped some people to secure some F1 interviews, and even one of our latest clients, your this person no that secured the job at we're not going to name it, but he secured this job at Aston, no?
Yep, yeah, we've had someone I helped recently secured a job at Aston Martin, and we've had a lot of people that sent us their CVs and we hadn't corrected with them. They've had F1 interviews, quite a few times. So I'd say it's a highly successful thing we do, and I think we're quite qualified to help out people on preparing them for F1 interviews and F1 applications and so on. A few more
But
questions.
of
Yeah.
course, if you reach the interview in the interview phase and you're applying for a performance or economics job and you don't have the skills, they're gonna turn you down. So you need both. You need the CV that looks nice, that makes it appealing for them to give you a call, but you're gonna be bombed with technical questions. So you need the economics knowledge as well, depending on when you apply.
Question, Javi. How in depth does the course go into suspension design?
The suspension design is covered around 2 hours, I believe. Unfortunately, I mean, suspension design is one of the things I like the most. I'm not going to say specialty because there are big words, but I really like it. And I got my own tools and everything, something that I really enjoy. But if I was to try to put everything down in a course, I think the suspension course itself will be like 10 of 20 or 20 hours. It's very complex to get everything completely right and really teach. I mean, you can teach the basic, what this angle is, what does it do with vehicle performance, blah blah. But like really getting the sense of design and what this does, and how to trade this with something else. This It's a longer journey. So currently at the moment it's around 2-3 hours, and yeah. But again, I think this is something I get a lot for Formula student. They they really, when they show their design report, they always start with suspension, when it's economics, and there is a very good reason why I've placed strategically the suspension geometry design at the end of the course, and is that I believe it is the pinnacle of the thing, but it's not the base. So you cannot understand what you're trying to accomplish with your suspension design, with your outboard or inboard geometries, if you don't understand what you're trying to optimize for, or what is the car doing, or all the full picture. So I think people tend to give more, like, it's important for sure, and in a car where everything matters, yes, but for me, it's one of the latest steps in understanding the car. What the suspension is doing, because ultimately the only thing that it's doing is controlling the wheel movement. But everything else that happens in the car, with the balance, handling, this and that, it's a much bigger picture than that. So
Yeah, absolutely. And at the end of the day, there's a lot of things. There's a lot of different ways of teaching the same thing. What we focus on is on actually giving you the tools and the understanding of how things work. It would. We don't want to give you any false information. And at the end of the day, so many things, especially about suspension design and vehicle dynamics, relies on so many different things. That there is no one formula, there is no one thing we say. We give you the tools, we give you the understanding, we show you how different elements affect different bits of your performance in your car and different properties of your suspension, and then we let you decide what your suspension really needs. Some more questions in the chat. There was a question on how to apply to this. You don't need to apply, you just book it on our website. So you go to racetrackdynamics.com and you can book it on there. There's a few spots left for December, and then we will announce the next date.
You want to put it on the group chat instead, Alex?
Group chat, as in the chat, yes. If you go, just to the main chat, main link here. Our website contains all the information you need to know about it. Someone asked, how does our course compare to like a semester of University of Vehicle Dynamics? This will obviously depend severely from university to university, but as we've said, there are universities that teach masters in motorsport engineering that use our course as their whole vehicle dynamics subject for a whole semester. So it will obviously depend, but it's clearly very dense. Lots of interesting topics, lots of valuable information, and it's definitely at the standard of what a Masters of Motorsport Engineering could be. There's a question on, can we arrange a session for interview preparation? That would be quite interesting, Javi, and let's make a note of that. See if you can do some sort of webinar or Q&A session or something about about like advice and guidance for university students.
Mm-hmm.
Cool. More questions. Ooh, a question for you, Javi. How hard is it to change from Motec to Atlas? And how many channels would a performance engineer normally check?
Can I get the question again? How
How
hard
hard
is?
is to change from Motec to Atlas?
Uh, I find Motec much more user friendlier, much easier, and more important, more robust. I mean, things change a lot with Atlas version and Atlas 9 and Atlas 10. They're very different. I mean, some of the robustness problems that they start in 10. But yeah, it's a much more complex Atlas 10. But I mean, Atlas, sorry, but at the end of the day, uh, you learn the software, the clicks that you need to do and what you can do, and the channels are there the same. If you read one channel, you can assign it in Atlas, you can assign it in Motec, and you get used to the specific software within 1 week or two, and then after that, you're good to go. But what you need behind is the understanding of vehicle dynamics, which is a little bit longer. So I got some questions in some of the students that we prepare for interviews and all, and I got the question that they wanted to move from the role they had to more data analysis, performance, blah blah in the team. And he said, "Hey, can you teach me, or should I learn?" I'm not going to name the simulation package that they were using. I was like, yeah, I mean, you can learn it, but what you're going to learn is how to click, and then you go to another team and they're going to have their own and they're going to have another one, and it's a never ending. So this is the thing with Atlas or Mote. What you use doesn't really matter as long as you are understanding you understand what you're doing. You have resources to do meaningful analysis and this sort of thing. So it's really just a matter of but yeah, I find that Motec is probably a better software generally for starters, although yeah, it doesn't really make a huge difference one or the other.
Cool. And quickly, as a quick point, how many channels could you normally work with, if you're allowed to say?
Um, I think probably over a weekend we're looking at the bare minimum 100 at the bare minimum,
100
100 to 100
channels.
minimum.
That's a lot of data. Had a question from Ishan about work experience in Formula 4 teams to 18-year-olds. At the end of the day, it really depends. What country you're based in, what's your experience, and so on. We can't tell you the available options for every team out there. And what we really encourage you to do is to check the websites of the teams themselves, and don't be afraid to apply. The more you apply, the more odds you have of getting a job, and you should get into the routine of looking at what you wish to achieve, what jobs you want, and trying to working towards them, and regularly checking for opportunities and so on. Javi, quick question. How is a performance engineer different from a race engineer, as they both do vehicle dynamics?
So a race engineer is essentially the role. A race engineer has previously served as a performance engineer, so he knows everything that a performance engineer knows, and then he's normally is a step up. So it's more responsibility. It's a little bit more operational. So you don't have now the time to look at all the sensors and this and that. You are more looking at generally managing the session, what you need to communicate to the driver. You need to help him to manage the traffic, the people that help him to read the race, help him to. It's a much more operational role. Not to say it's not technical. It's very, very technical, highly technical, especially to, all the limitations, performance limitations. It's the role of the race engineer to solve them after the session, then to think, okay, what do we have during the session? This, that. Okay, I need to do this. He has a big team helping. But yeah, generally, it's I would say the main difference is even more operational, more hands-on, much more. Both are very quick reactions, very, very lively, but race engineering, sorry, it's a step up.
Cool. Would you then say that it's a common path for vehicle dynamics engineers to then become performance engineers and to then become race engineers. Is that a kind of usual path, Javi?
I think it is. I think that it's yeah, it kind of is. Yeah.
Yeah, absolutely. Which is why I mean we like vehicle dynamics so much because it allows for so many such a wide range of job opportunities. And I mean, a lot of people, I'm guessing, want to become race engineers at some point. Uh, it's one of those that people wake up in the morning and say, "Oh, I want to be like GP. I want to be like someone else. I want to be the one on the radio with the driver and so on." And it's one of the things that vehicle dynamics allows you to do, but something that you also need to be really good at, which is vehicle dynamics, which is why we do everything that we do. We're gonna have you, shall we say, 4 more minutes until a clock of questions, and then we call it a day.
All right, we can do that.
Cool. Question: is there any playlist on YouTube for a better understanding? You've got our reels and our YouTube shorts. You can find them on all of our social media platforms. We've got probably close to 30, 40 reels now explaining
We
in
are
short.
we are everywhere now.
Yeah,
I mean,
in
our main intention with all this project was to make all the knowledge accessible to everybody, to spread. We believe this needs to be open. It is everybody that wants to chase this dream. They need to find the information. It has to be easier for them. So that's why we move now to streaming this kind of webinars in YouTube, and hopefully to keep reaching more and more people and enthusiasts that want to develop their paths towards this. So yeah, that's why we take care of all the social media. We started to put videos in TikTok, Instagram, really everywhere. I've never been a fan of speaking in front of the camera and doing these videos, but we believe it's the best way to reach people and to try to to spread a little bit.
Yep, cool. We're gonna do a final question. We're gonna final question. Question from Giovanna. Are the seminar spots running out? The answer is yes. We limit the spots on our webinars and our courses. So that we can ensure we can spend enough time with each particular person. We can dedicate the time that you deserve and the time that you need to understand everything properly. Which is why we have to limit the attendance, which is why we've run out of spots. That happened in September, we ran out of spots, and now if you can see on the website, there's about 7 spots or something like that, last time I checked, about an hour ago. If you want to get yours, don't wait too long, as it might be too late. Anything to add, Javi?
Oh, that's it. I think we share the certificates. Everybody knows where to get them. We're looking forward to see them the posting on the media.
Cool. Yeah. Thank you very much. Then we will send out the certificates within the next hour or so. Feel free to post them on Instagram or LinkedIn mostly, or anywhere that you want. We will repost whenever we see it. Feel free to tag us. We might even comment some nice things. And yeah, thank you very much for being here. It was a great pleasure to have a total of 723 people joined us today, Javi. Which is a pretty good number, I'd say. We hope you all find it useful. Feel free to follow us on Instagram, TikTok, and everything. We post free content for vehicle dynamics, learning, and so on. If you have any questions, you can send us a DM or you can send us an email. Don't forget about your certificates. And thank you very much. We will call it a day here.
Thank you very much, everybody, for joining us today. Thank you.
Thank you. Bye-bye.